Dear students, it is lecture number 2, Chemistry of Lanthanides. In this lecture, we will discuss the following topics: electronic configuration of lanthanides, lanthanide contraction, what are the causes of lanthanide contraction, and what are the consequences of lanthanide contraction. In this lecture, we first start the trick to write the electronic configuration of lanthanides. Students, as you know that electronic configuration of lanthanides is written in the sequence 4F, then 5D, then 6S. How many electrons are to be placed can be explained in this way as given in the table. First, write the elements in sequence from cerium to lutetium. In row number 2, write the atomic number of all elements, 58, 59 to 71. And third row is written in this sequence 1 to 14, but cross the number 2 as shown in the table and 8. These two numbers which are have been crossed shows that these two numbers are not filled in F subshell. How? Electrons in F4F subshell are to be filled. Let us check the row number 4, electron in F subshell. In first element, 1 electron. Seventh element, 7 electron, bolded here. And in 14th element, 14 electrons in F subshell. Now, in other subshell, in other elements, how many electrons are to be filled in F subshell? Promethium, 3, not 2, 1, then 3, 4, 5, 6, 7, again 7, which has already placed 7 and 14. Not 8, 9, 7, not 8, 9, TB, 10, dysprosium, 11, 12, 13, 14, and 14 was already placed. So in row number 4, 7, 14, in 7th element, 7 electron must be placed in F subshell, and in 14th element, 14 are placed. But two numbers are not used in filling the F subshell. In first element 1 in F, 3, not 2, 4, 5, 6, 7, 7, 9, not 8, 10, 11, 12, 13, 14, and 14. I repeat again. Electron in F subshell, 1, then the cross 2 will be missed. In next 3, 1, 3, 4, 5, 6, 7. This 7 which have been bolded and 14 bolded, these are written first of all, then other electrons are written. It means in cerium, 4F contain 1 electron, promethium 3, not 2, which have been crossed, 4, 5, 6, 7, 7, 9, not 8, 10, etc. up to 14. How many electron in S? 6, S2 in all cases, 2, 2, 2, 2, 2. How many electron in D sub must be placed? In first one, 7th one, 14th one. All other D sub shall have 0. How the number of D electron can be calculated? The formula used is xenon, atomic number of xenon, plus in last row, check the last row left side. Xenon plus electron in F, you know, 1 cerium, 2 in promethium, and 2 and 8 have been crossed. These numbers are not used in F subshell. Electron in D to be calculated, plus electron in S, that is 2, is equal to atomic number of the element. For example, cerium, 54 xenon, 1 in F, check in table cerium, 1 in F, X number of electron in D are to be calculated. 2 in S is equal to 58. X plus 57 is equal to 58. X is equal to 58 minus 57 is equal to 1. It means 1 electron in cerium in which subshell? 5D1. In next slide, all calculations have been shown. Check these calculations carefully and make your concept clear for writing the electronic configuration. I repeat again, in first element cerium, in 7th and in 14th element lutetium, 1 electron are placed in D subshell. All other D subshell are empty, having 0 electron. The D subshell, which one D subshell? 5D subshell. Now I have completed the electronic configuration of cerium 58. Match it with the table which is used to explain the trick. Fail all other yourself, you will succeed inshallah. Now read this slide carefully. I read just 2 or 3 lines. From the above electronic configuration, it can be seen that a lanthanum 5d orbital is singly occupied. But after lanthanum, further filling of 5d orbital is discontinued in certain cases. In many cases, they contain 1 electron, etc. Read this slide carefully. Everything will be clear about the electronic configuration. Now we discuss the lanthanide contraction. The lanthanide contraction is greater than expected decrease in atomic radii and ionic radii of element in lanthanide series from atomic number 57 to 71, or the decrease in atomic radii or ionic radii of lanthanides as we move from left to right in this series is called, this decrease is called lanthanide contraction. Why lanthanide contraction occurs? Check this diagram. The size atomic radii of the lanthanide decreases as we move from lanthanum to lutetium or cerium to lutetium. Why lanthanide contraction occurs? There are many reasons. Number 1, as we move from left to right, after every step 1 proton is increased in the nucleus. It means as we move from left to right in lanthanide series, the nucleus become powerful on moving from left to right in this series. The 4f subshell electrons have poor shielding effect. As a result of it, the nucleus applies stronger attraction over the valence electron. As a result of it, electron clouds slightly shrink. This shrink in size, this shrink in electron cloud results the lanthanide contraction. What are the consequences of lanthanide contraction? Atomic size. The atomic size of third transition is nearly same as second transition series. Difficulty in separation of elements. The atomic radii are almost same, so the separation of element from their compound is difficult. Effect of strength of hydroxides. As we move from left to right, the atomic size goes on decreasing. This decrease increase the covalent character in hydroxides. Complex formation due to high nuclear charge and small size. The complex formation ability increases from left to right in transition series, and electronegativity almost matched to S block elements. It increases from lanthanum to lutetium. Thank you. Repeat it again and again and clear your concept.